Okay, so since we just talked about central angles and minor arcs and major arcs and semicircles, it's time to introduce a few more theorems. Again, a theorem is just a math rule that's been proven to be true all the time, okay? So, in the same circle or in congruent circles, it works for both, two minor arcs are congruent. That means they're the same size if and only if their corresponding chords are congruent. So, what this is saying is if you have two arcs that are congruent, then automatically the chords that make these arcs have to be congruent as well, and vice versa. If a diameter of a circle is perpendicular to a chord, then that diameter bisects the chord or the arc. Bisect means it cuts it into two equal pieces. So we have two rules here, and we're going to use at least some of those rules in example 22. We want to find the measure of arc AD. Alright, well first off, the first thing I need to notice about my picture is I have these little lines right here. Those little lines mean that these two chords are congruent. Again, I know they're chords because it's a line segment that touches the circle in two places. So, I'm just going to write out what I know. Line segment AD is congruent to line segment DC. That was given to you. Okay? And those are chords, because they each touch the circle in two spots. Okay? Now, in my rule that I just said, two minor arcs are congruent if and only if their corresponding chords are congruent. So since my chords are congruent, that's what was given to me in the picture. That means, based on my rule, that means the minor arcs, so corresponding minor arcs, are congruent. Now, instead of congruent, I just use the math symbol. It's an equal sign with a squiggle on top. That means congruent. Same size, same shape. But essentially, if you want to think of it as an equal sign, it's not technically right, but it would be good enough for our purposes. Alright, so corresponding minor arcs are congruent. So what that means is arc AD is congruent to arc DC. That's what we're saying, using math language. I'm just writing it out that way you kind of get an idea for the feel for it. All right, well, since these two are congruent, that means now these are essentially the same. If it's the same, then the symbol we're going to use for the same is equals. So 2x is equal to x plus 40. Pretty easy. Now we want to solve this equation. I'm going to subtract x from each side. Cancel out. So x equals 40. Oops, and that was terrible. X equals 40. Now, we didn't really care about what x equals 40. We wanted to find the measure of AD. Okay, so always pay attention to what you're being asked. So I want to find the measure of arc AD. So from here to here. So what I need to do with my x now is plug it in. So the measure of AD is what I'm trying to find. Measure of arc AD. And we know that AD, based on the picture, is equal to 2x. Well, I know what x is, so I'm just going to plug in now. So 2 times 40, which is 80. So the measure of arc AD is 80. Okay, so you got to pay attention to what you're being asked for. Well, again, all we did was use these two rules. Be sure you know these rules. It's very important because you're going to have questions like this on the quiz, test, and final. I promise you. If you don't know them, you're just going to kind of look at the picture like, what do I do? What do I do? Make sure you know these rules. Okay, another rule. In the same circle and congruent circles, two chords are congruent if and only if they're the same distance from the center of the circle. Distance is always perpendicular. So you should see a little box, which we do see those little boxes in example 23. So again, we're measuring distance. We're told that AB is 8, DE is 8, and CD is 5. We want to find CF. Alright, anytime they give you information about a picture, I suggest you plug that picture in. And I'm going to do this based on colors. I'm going to do AB in red. We're told that AB right here is 8. We're told that DE, let's do that in green, DE, which is right here, is also 8. Okay? And then we're told that CD is 5, which is right here. I'm just filling in my picture with the information that's given to me. I want to find CF. So this is what I want to find right here. Okay? Well, I know, based on the rule that was given to me, that these two chords are congruent if and only if the distances are the same. Obviously, my two chords are congruent because DE and AB have the exact same measurement. So I'm going to start off with that. Chords AB is congruent to chord DE. That was given to me. And what that means is the distance from the chord to the center of the circle should be the same. Okay, so the distance CF should be congruent to the distance CG. Now you got to be careful here because CG is the distance from the chord to the center. Again, distances are always perpendicular. So the distance is not 5. If you think the distance is 5, it's wrong. The distance is always perpendicular. So I'm looking for that box. So that tells me what piece is the distance. Now what we need to do is first find CG. Okay, so the next step is going to be to find CG. We want to find that distance. The reason why I chose CD is because down here is where all the numbers are. If going from here to here is 8, then this line, since it's a distance and it's perpendicular, it bisects this chord, which means it cuts the chord in two. So DG is 4. Okay? So since CG is perpendicular, this upside down capital T, upside down capital T means perpendicular. Since CG is perpendicular to DE, it is a bisector. And what that means is, based on the numbers, is that DG is equal to 4. Okay, and I'm putting that information on my picture. Now I have a right triangle. As soon as I see a right triangle right here, I'm going to think Pythagorean theorem. Okay, so Pythagorean theorem. A squared plus b squared equals c squared. Again, if I look at my picture, c is always my hypotenuse. The hypotenuse is always across from my 90-degree marker. So c is 5, and I'm going to call the piece that I'm trying to find, I'm going to call that x. Okay? So I have x squared plus 4 squared equals 5 squared. Now I want to clean this up and solve. So I have x squared plus 16 equals 25. Subtract 16 from each side. So x squared equals 9, which means that x has to be 3. So now that I know x is 3, I'm going to put that in my picture. So right there is 3. Now we were told, so now we know CG, so that we now know CG is 3. That's what we see in the picture, CG. But we know CG is congruent to CF. That means they're the same. So CF also has to be 3. And since CF is 3, that's what we're trying to find. CF equals 3. That's my answer. This is a long, drawn-out problem. I kind of just wrote out my thoughts, my thought process. I went back and forth from the picture to the algebra, from the picture to the algebra a lot. You're going to need to do this with these geometry problems. Some people are visual people like I am, and geometry is actually easier for them. Some people are just straight up algebra, and these, when you throw a picture in, it really starts to mess you up. hopefully you're a visual person like I am. But if you're not, please ask questions, get help, because I want to help you. And that's it for this video.